or the secondary alcohol. Jaslin, Marwa, Aisha, I hope all of you can hear me. Yeah, which alcohol can liberate H2 most easily? Okay. It is the primary alcohol, methanol, followed by secondary, and then the tertiary alcohol is the least reactive. Ethers will not liberate hydrogen. So what is the reason why ethers will not liberate any hydrogen gas with sodium? What's the reason? Ibrahim, Jaslin, Mara, tell me quickly. What's the reason why ethers will not react with sodium? Am I audible to all of you? Yeah, Aisha, am I audible?
Yes, sir.
Okay. So just we were trying to recap the previous class, okay? So I was discussing that reaction with sodium, and it is also a test to distinguish between alcohol and ether, right? Alcohols can liberate H2, ethers cannot. Got it? And as far as the replacement of by hydrogen is concerned, the primary alcohol are most reactive, followed by secondary and then the tertiary. Got it? I hope it is clear to all of you. Reaction with the base, acid base reaction, acidic hydrogen we have seen. Why phenols are slightly more acidic than water? Marwa, could you explain it to me? Just quick few words. Can you explain it to me? Why phenol is slightly more acidic than water? Why it can lose its H plus? All of you, Marwa, just try to figure out. We have studied in the previous class. Who can tell me? Aisha, Jaslin, Ibrahim. Why phenols are slightly more acidic than water? Tell me quickly. Very simple. All of you know it. You can do it. Tell me. Why it is more acidic than normal alcohols?
Because of the resonance structure.
Because of the
Resonance?
because of the resonance. Okay. Once you remove the H plus, the conjugate base which you get, okay, that is stabilized by resonance. Okay, so H plus and that negative charge spreads on the benzene ring. So it weakens and that H plus is separated from phenol. Where the negative charge come when it undergoes resonance, it is at ortho paraposition. Okay. Acidic strength of phenol. At ortho paraposition, if there are more electron withdrawing group that can undergo resonance, it is going to be more acidic. Okay, for example, there is NO2 group which can pull the negative charge. So this is more acid. Is it clear? So let me take one question, very easy question. And it is based on the previous concept, but this concept is so important that we need to recap it. This is phenol, right? And Ibrahim, which is the next molecule?
What's it?
What is the name of this molecule? Second one.
Uh, Anything. Yeah.
No, this is phenol only. It is OH, but there is a nitro.
Ah, yeah.
group.
Nitrophenol. Oh, nitrophenol.
Yeah, para-nitrophenol. Got it?
Paranitrophenol.
The para means or 4-nitrophenol. Okay, if you want to write the IUPAC. And what is the name of this compound? And this one. They are very important, Jasleen, Aisha. Yeah, orthopara dinitrophenol. Yes. Because this is the principal function group 2,4-dinitrophenol. Got it? This is the IUPAC name. 2,4 is IUPAC. Orthopara is the common name. And what is the name for the last option? IUPAC name that is also very famous. Yes, 2,4,6-dinitrophenol. And there is also a common name to it. Very common. And yes, Jesslyn, exactly. This is picric acid. Marwa, is it clear or not? Picric acid.
Yes, sir.
Okay. And I am putting more and more NO2 groups. So Aisha, Jesslyn, Marwa, what will be the order of acidic strength? Which one do you feel is going to be most acidic and which one do you feel is going to be least acidic? Tell me quickly. I'm talking about the acidic strength, right? Look what has happened with the NO2 group. You can see this minus charge. Just a quick recap of the previous class. Can everybody see it? Okay, what happened to the minus charge after you remove the OH group? That minus charge is actually moving within the ring. But is it coming at all the positions? The answer is no. Okay. It is coming at ortho and para position. Got it? Once you put the NO2 group at ortho and para positions, what happens? This minus charge delocalizes further on the NO2 groups. Is it clear or not? The minus charge spreads on the NO2 because NO2 is also having double bonds. But for that, the NO2 group should be present at ortho and para positions. And in this question, we have placed the NO2 at the ortho and para positions. Can you see it, Ibrahim?
Yes.
Okay, so tell me what is the acidic order of acidic strength? What is the acidic strength? When you put more and more NO2, it becomes more and more acidic. Got it?
Yes, sir. Yeah.
So it is going to be like this. Okay? Because the minus, that once you have the negative charge, acidic means it gives H plus. Okay? It releases H plus. And but H plus all of the molecules can release. What's the difference? The difference is with not respect to H plus, it is with respect to the O minus. It should get stabilized by the NO2 groups. So more and more NO2 groups, more will be the acidic strength. Is it clear? Ibrahim, what's the common name for this compound? It is the phenol with the CH3 group. I hope you can see it.
Sir,
What's
cresol,
the common?
cresol.
Cresol, yes, paracresol, metacresol. Orthocresol. So is the cresol more acidic or less acidic? Than phenol that we have seen. What you have put methyl group. Is this methyl group taking away the electrons more? Just check it and tell you. Or is it giving the electrons? Tell me quickly. Ibrahim. The methyl group is giving the electrons or taking away the electrons? Yeah, Aisha, less acidic, right? Exactly.
Gives.
Okay. Yeah, Jasleen. Actually, this is phenol should be most acidic, okay? Because this methyl is electron donating group. It is not like NO2 which is having electronegative atoms. It is giving electrons, okay? And where it is giving most, and if it is giving, the O minus will become more minus. If it is becoming more minus, why it will lose H plus? It will not, it should not lose H plus. It should become less acidic. I hope everybody understood the concept. So that minus charge is coming at ortho and para positions. So this one and this one is going to be least stable. The O minus, the conjugate base is going to be least stable for B and D because the methyl is present at the ortho and para position. So it is going to give its electrons, okay, by inductive effect. So D is least acidic, then B, D is least because it is closest to OH group, so it is giving more electron density. It is making O minus more negative, being nearest. Got it? And if O minus is more negative, why H plus will go away? H plus will not come out. A, this is C. C is bit more acidic because the methyl is not able to, it is not present at the position from where the negative charge is passing. So it is not able to give its electron to the negative charge. Okay. Is it clear? Methyl is electron donating group, and it is going to affect if the methyl is present at ortho and para positions. Out of ortho, so the ortho and para positions, more electron donating effect of the methyl will be there. Out of which the ortho position is most electron donating because it is nearest to the OH. So, and this is making O minus more negative because CH3 is electron donating group. Okay. So D is least acidic. B, C, and D have methyl groups, so they are less acidic than the phenol. Like in the above case, we had electron pulling groups. So if you put NO2 group, it will become more acidic than phenol. But in this question, you have put electron donating group. Electron donating group will make it less acidic than the phenol. And wherever the electron donating effect is maximum, there the acidic strength is going to be least. That is for ortho position where the methyl is nearest. Then para position, you may say that the para position is farther, but still the methyl is giving its electron density because the minus charge is passing from the para position. Meta position is bit safe because the minus charge is not passing directly. Uh, on the from the places where the methyl is attached. It is not passing directly where from the place where the methyl is attached. Okay, so this is more out of these two. Okay, and A is maximum. So this acidic strength of phenol is clear to all of you. Tell me quickly. Any doubts in this? Aisha, Marwa, Jasleen, anything need to be, because this is going to come in your examination, very important. Okay, you can also go through it. Just ask me the doubts. Okay, in the class itself, you can stop me if there is any confusion. Okay, I will explain it again. Is it clear or not? Any doubts? Let's okay, good. So let's move to the next reaction related to the hydrogen of the alcohol. We have seen reaction with bases. We have seen reaction with sodium, that is liberation of H2. Okay. We have seen the acidic nature of alcohols and phenols. Now the third reaction, which is basically the related to the H of the OH, is acetylation reaction and esterification reaction. So you take an alcohol. It could be a normal aliphatic alcohol or aromatic alcohol. You react it with the carboxylic acid. Carboxylic acid. Which carboxylic acid it is? Ibrahim, can you tell me? Which carboxylic acid is this?
That's ethanol.
Ethanoic acid.
Ethanol acid.
Got it? And when you heat it in the presence of concentrated H2SO4, concentrated H2SO4 absorbs water, it removes water. Concentrated lacks water, so it removes water. Do remember this? So water will be removed from alcohol and carboxylic acid. If I remove water, what I have put this mark for the removal. So choose the atom which are need to be removed. Is it clear? So what I got, this is ester. This reaction is known as esterification reaction. Esterification means making of esters. Is it clear? H2O I can write here. H2O actually it will be absorbed by H2SO4. Can you name any of the characteristics of esters? Any characteristics of physical characteristics? Yes, fruity smell. So the fruits actually have esters in them and that is responsible for the fruity smell. So this is ester. This reaction is esterification. If you take dilute condition means lot of water is there. So if lot of water is there, water will not be removed, it will be added. Got it? So this is a reversible reaction. You can control whether you want ester or whether you want to have the ester being cleaved to alcohol and carboxylic acid. The forward reaction is esterification. This is also a test for alcohols and carboxylic acid. When you mix them together, in the presence of concentrated H2SO4, you get a fruity smell. The reverse process, when you take lot of dilute H2SO4 means lot of water is there. That is ester, that is not making of ester. The backward reaction is breaking of ester with the help of water. Is this clear to everyone? Any doubts in this? This is hydrolysis. Yeah. Clear to all of you?
Yes, sir.
Esterification and ester hydrolysis. Okay. If you take some different alcohol, you may accordingly you may get the ester from that particular alcohol. Let's say suppose if you have taken CH3OH. If you have taken CH3OH And let's say you have taken propanoic acid. Got it? So, and if you do the esterification, the ester which you are going to get, concentrated H2SO4 will lead to removal of water. Ester you are going to get is methyl ester. Got it? So first write the acid. This was the acid propanoic acid. But instead of OH, put the alkyl group of the ester, OCH3. So this is methyl ester, known as methyl. How the esters are named? O8 is the characteristic name of esters. O8, right? So methyl propanoid. Got it? Let's do a very simple question. Ethyl methanoate can be prepared by the esterification of you need to choose two options. One should be alcohol, another should be acid. Ibrahim, are you there?
Yes, sir.
So tell me, which two options should we heat, bring them together and heat with concentrated H2SO4 so that we can get ethyl methanoate. Got it? Read the name very carefully. I told you how to name the esters. For the reference, you can see the above name.
So ethyl propanoate. So the non-ester part will have ethyl. Yeah. So two C2H5.
Yeah, that
Okay.
ethyl is there. Yes. CH2, CH3.
Yeah, C2H5.
Then you have
And
the
then
COO, acid part. Okay. The part which came from acid. The part which came from acid has O8 attached to
yeah.
it.
So it'll be the fourth one. Yeah, fourth one.
Yes, exactly. Methanoate means only one acid of one carbon atom. So it will be fourth. And this is the acid part, and the alcohol part also you should choose. Okay. Which alcohol part? First or the second? Second, because this is the alcohol
Second
part,
one.
right? Got it. So 2
Ethanol.
and 4 are the right options. Is it clear? to all of you. Marwa, is it clear? Now, what
Yes.
we need to do is another part is that Jesleen and Aisha, that not only you get esters from carboxylic acid, the other carboxyl, listen to me very clearly. This is going to be very useful. Carboxylic acid derivatives containing oxygen. What are the carboxylic acid derivatives which contain oxygen other than uh, and chlorine? That is acid chloride and anhydride. They can also be used to get the esters. Okay. Esters can be prepared. Esters can be prepared by what? They can direct answer is by heating alcohol and carboxylic acid. That is the direct answer. But other carboxylic acid derivatives may also be used for the preparation of esters. And what are those carboxylic acids? When they are reacted with alcohol, they can give esters. So this is methanol. This is an alcohol, all of us know that. But instead of using acid, we may use a carboxylic acid derivative. Okay, this was the carboxylic acid. Got it? So we may use this. Got it? Acetyl chloride. We can end up with esters. Is it clear or not? So we can use other carboxylic acid derivatives also. But what will be removed? Is water going to get removed? Yeah, Ibrahim, tell me. What will be removed in order to get ester?
The chlorine.
Yeah, H and Cl, right? Is it clear? You need to remove HCl. But HCl is an acid. How can you remove an acid? We need what? To remove an acid, what we need? We need to heat it with a base. Okay. And what is the base? The base is a very famous base, molecular base. It is known as pyridine. Is it clear? This is the formula and this is the structure. In case if you want to know the structure also, I have given you the name, the formula, the structure, all the three names. Got it? So what is the role of pyridine? Ibrahim, can you summarize it for me?
The
Why we
pyridine
have
you
taken?
remove the
Why we have taken the pyridine? Yeah.
to remove the HCl to form an ether.
Yeah, pyridine is a base, it is used to absorb HC. Okay, there we used concentrated H2SO4 to absorb water. Okay. So this is CH3O, CO, CH3. Got it? Other way could be to use other carboxylic acid, and that is anhydride, right? So this is it looks like this. Acetic anhydride. It is known as acetic anhydride. Got it? So if I want to make ester out of it, what do I need to remove? Alcohol I have given you in front of you, it is there, right? CH3OH. H and this OCOCH3. Acetic acid I need to remove. So I will write minus CH3COOH. Got it? Is it clear? I can use the pyridine because pyridine is a common as base which can use absorb HCl and other acetic acid. Marwa, are you getting it?
Yes, sir.
So we are going to get this minus above arrow I have written minus CH3COH, mean that is being removed. Either you can write it above arrow, or if you don't write it above the arrow, you can write it as a byproduct. Is it clear to everyone? You can write it as a product, byproduct, CH3COOH. I hope this is clear to all of you. Got it? So this is also known by the name of acid because you are using acetyl chloride and acetic anhydride. These come under the heading of acetylation. Got it? Acetylation is a very common reaction. So it is none other than the esterification. And you are putting the CuCH3 group in place of H. I hope it is clear. So let's try to find out a common application of this reaction. Okay, what is the common application of esterification? That we all know. Okay, you must have studied in your class 10th also that esters have fruity smell. They have wide industrial application in foods and all. Okay, they have fruity smells. Okay, they are also used to identify alcohols and carboxylic acid in the chemical reaction. Once we get the fruity smell, we can make out, okay, we had alcohol and carboxylic acids together. Okay. If you use COCH3, that is acetylation. Is it clear? And you can, apart from carboxylic acid, you can use CH3COCl and CH3COOCH3 to get the esters, right? Let's see it in a one more very famous reaction and an application of this esterification reaction in the field of medicine. Okay. So you have this acid. Can you see this acid? What all functional groups are present, Ibrahim, in this? Can you tell me?
The phenol, OH, and carboxyl.
It is carboxylic acid and COH and the OH. Okay, this carboxylic acid has a name salicylic acid. Got it? Marwa, is it clear? So what is salicylic acid?
Yes, sir.
So it is the phenol with COH group at the ortho position. Got it? Salicylic acid, you can react it with CH3COCl. We are doing the esterification. I just now told you that you can use acid chloride and acetic anhydride to carry out the esterification. Is it clear to everyone? So we can use this. What are we going to get? If we have used this, we can write minus HCl. Okay. And where this COCH3 group is going to attach, on the COH or on the OH? We are doing the esterification, right? So it is for the alcohols. So this H and Cl we can remove, Aisha, or we can remove this COCH3, OCOCH3 and H plus. Or I am writing, okay, whatever, it depends upon whatever you choose. Minus H got it. So what we get and what's so special about it, Ibrahim? Ibrahim, what's so special about it? Can you tell me?
This is it's a medicine, yeah, this one.
Yes, very common medicine which all of
Aspirin.
us know. Yeah, aspirin. Okay. Right? This is aspirin used for as a painkiller, used for the treatment of fever, right? So Ibrahim, can you tell me just in the Viva also they can ask in the schools? Okay, this is so common, right? So they will just ask you how aspirin is prepared. So what you will say? In the Viva they can ask you like this. In the school practicals also.
So will react salicylic acid with
With
CH3 CO whole twice O.
yeah, acetyl chloride or acetic anhydride. Okay, that is acetyl
In the
chloride, the one
presence
on
of
the top. Yeah, and HCl or acetic acid will be removed depending upon whether you have used acetyl chloride or acetic anhydride, and you will end up with aspirin. Okay, can you read out the name for me?
2-acetoxybenzoic.
Got it? Is it clear? Very, very common. Or another common name, this is acetyl. Acetyl salicylic acid. Got it? Is it clear or not? But it is very important, Marwa, is it clear to you? Because this is going to be there in the two chapters.
Yes, sir.
Okay, one is this place alcohol, and it will again be there in the carboxylic acid. So it is there in the two chapters, so very important. So acetylation of salicylic acid, the OH group gives us acetyl salicylic acid, which is aspirin. Okay, this much we should remember. Okay, basic thing, the structures, just little bit you can write. Okay, once you can write them, you will feel very much confident. Okay, you can clearly will be able to recall the reaction in the future. Got it? Let's move to another reaction. And this reaction was used for the identification of alcohols. Okay. And we are also going to move towards another class of reaction. What is that another class of reaction? Till now, we were looking at what type of bond cleavage. What type of bond cleavage we were looking at till now? ROH. We were looking at the OH bond reactions related to OH bond. All the reactions of the alcohol above this line, we had OH bond being broken. Is it clear? Now we are going to look at another class of reaction. This is the breaking of carbon oxygen bond. So what will be the rate of this reaction? Can you tell me? Yeah, Ibrahim. How this bond will break? First tell me. Is it going to break as R minus and OH plus, or R plus or OH minus?
I think in this case it will break as R plus and no, R minus and OH plus. I think. No. No,
we
R
can,
minus and no, R plus and OH minus.
yes, R plus and OH minus. Why you chose this? Absolutely correct. And why you have not chosen this R minus and OH plus? Why not the
Because
other
oxygen will have excess. Yeah. Oxygen has excess electrons. That's why.
Oxygen is an electronegative atom, we all know. Okay. And
So like
oxygen,
it can't have a positive
yeah,
charge.
it loves to have a negative charge. Got it?
Mhm.
It is very stable if it has negative charge, right? And we are going to break the bond like this, so that we can bring the negative charge on the oxygen. Is it clear to everyone? Marwa, is it
Yes, sir.
clear? Ibrahim? So this method is correct. Got it? So R plus and OH minus. And what's the stability of R plus? R plus, tertiary cations are more stable, followed by secondary, Jaslene, then primary, and then CSC. Got it? Why is it so? Why this is the case? Why tertiary cation is more stable? Ibrahim, can you tell me? Jaslene, Aisha, what's the reason that the carbocation having more number of carbon atoms is more stable than a cation with less number of carbon atoms? What's the reason?
The positive inductive effect.
Yeah, inductive effect plus I effect. Exactly. So this CH3 group is electron donating group. It exhibits plus I effect because carbon is not that much electronegative. Okay. So it exhibits plus I effect, right? Okay. And it is pushing its electron density towards the plus charge. Plus charge is getting the electrons. So it will become stable. Is it clear? Because what plus wants? Plus wants the electrons. And there are 3 methyl groups. In this case, you have just 2 methyl group, just 1 methyl group, and there is no methyl group. So this is the order of the stability. Is it clear or not? Any doubts on this? So this is why we all of a sudden, while doing the reaction of alcohols, we started discussing the stability of carbocation because that's how the bond breaks and that's how the carbocations are formed when the different alcohols are being reacted. And if a carbocation is more stable, then that alcohol will easily lose the OH. Are you getting my point or not? Plus I effect increases and the stability increases. And this is the rate. This is not only the stability of the carbocation. This is how the alcohols are going to react when the OH is removed. Because when the OH is removed, you end up with the carbocation. Okay, that carbocation, whether it is stable or less stable. Okay, that depends upon whether it is primary, secondary, tertiary. Got it? Marwa, Aisha, is it clear or not? Jasleen, Ibrahim.
So,
Clear, very important because lot of reactions are based on this. All the reactions where you have OH bond being cleaved, you will follow this rate. Got it? So let's proceed with the reactions. Okay. I am going to write the reactions of alcohol. Yeah, you can check your connection. Maybe the connection is slow, your connection. My side, the connection is okay. Let me check it. So reaction of alcohols, right? Involving carbon oxygen or RO bond. Cleavage, right? So there are different reactions, but the rate is going to be like this only. One reaction is Lucas test. Ibrahim, what is Lucas reagent?
Is it HNO3? Yeah.
No. Aisha, Jasleen, Marwa, tell me quickly what is Lucas reagent? What is Lucas reagent?
It helps like to get the difference between the alcohols.
Yes, yes, exactly. So it helps us to identify different types or differentiate between different primary, secondary, and tertiary alcohol. So what is Lucas reagent? Yeah,
Zinc
absolutely. Yeah.
concentrated chloric acid.
What it is? Pardon?
Zinc chloride in hydrochloric.
Yeah, it is the HCl and the ZnCl2 is the catalyst. And nitrous ZnCl2 means it should be dry, not with the water. Okay. And what's the when you treat this alcohol with HCl, ZnCl2 taken as a catalyst, because we are dealing with the reaction where the OH bond is being cleaved, okay, or and you have a cation. This is SN1 mechanism. Got it? In SN1 you had cations being formed. Okay, if you go by the mechanism, or just remember carbocation is formed and you have the OH being removed and Cl in place of OH. Got it? So how the reaction occurs? The reaction occurs most quickly for tertiary, then for secondary, primary, and for CSC. Got it? Tertiary alcohol. And how you know whether the reaction has happened? What's the characteristic of the product? Can you tell me? How you know? What's the characteristic of the product? Can you tell me? Yeah, Ibrahim. How do you know that the reaction is completed? Tell me quickly.
So when we get HCl and when we get a stable carbon atom, I think.
You have haziness appearing in the reaction mixture, or cloudiness, or turbidity. Is it clear or not? So what you do, you note down the time for the appearance of this haziness or turbidity. And that let you decide whether the reaction has happened instantly or it has taken or it has not occurred at all. Okay. This for tertiary alcohol, this is instant turbidity. The turbidity appears instantly the moment you put the reagent reaction get completed. Why? Because the tertiary cation is being formed and that can form most easily. It is the most stable one. Got it? Secondary will take some time, 5 minutes or 5 to 10 minutes. Okay, or more than 5 to 10 minutes or 5 minutes. Okay. Primary alcohol, no turbidity. Means no reaction. Or only upon heating, it can give the turbidity. So the reaction is same for all the three types of alcohol. But for tertiary, it has taken place very quickly because the tertiary carbocation was very stable. For secondary, it took bit more amount of time, and for primary, Either it has not occurred or may have occurred after half an hour. Okay, after a long time. Got it? It is because of the difference in their reactivities. This is Lucas test. It is used to identify different types of alcohols. Is it clear or not? The test, how it can be used upon putting reagent, how much time is needed for completion of reaction for the appearance of turbidity, that helps us to decide whether the alcohol is primary, secondary or tertiary alcohol. Got it? I hope this is clear to all of you. Any doubts in this? Marwa, tell me.
Yes,
Primary
sir.
alcohol will take long time, it will be very slowly reacting. Okay. Tertiary alcohol means the alcohol which has OH group connected to a carbon which is connected to three other carbon atoms. Okay. That is tertiary alcohol. That will give instant reaction, instant turbidity. Can everybody see the question? Can all of you see the question? Ibrahim, Jesslyn, Aisha,
Yes, sir.
Marwa, can you see the question? So which alcohol is going to give instant turbidity with Lucas reagent in Lucas test? The answer is, the concept is written in front of you. So just tell me quickly. Aisha, you need to check where the OH is connected. Got it? Where the OH is attached, right? Yes, Jasleen. And how many carbon are attached to the carbon atom containing OH group? You need to check that. Okay. So this is the answer because this is the tertiary carbon. Okay. Aisha, tertiary carbon is there here also, but the alcohol is not tertiary. Okay. Because the OH is secondary alcohol, right? This is quaternary carbon. But the OH is not connected there. We should look at the carbon atom on which the OH is present and how many carbon atoms are connected to it. So Marwa, which alcohol is this? Is it the primary alcohol, secondary alcohol, or tertiary alcohol? Marwa, can you see it? Ibrahim, Marwa, tell me quickly, which alcohol is this?
Tertiary.
Is it primary, secondary, or tertiary? The option A. I'm asking about this one.
That's primary.
It's a primary alcohol. Why?
No, because the OH is attached to a carbon which is attached to only
Yeah.
one carbon. That's all.
Yeah. Yes, Jasleen. It is attached to only one carbon, so it is primary. Marwa, is it clear or not? This is also primary.
Yes, sir.
Primary carbocations are not stable. That's why, yes, attached to CH2 exactly, Aisha. So that is why the primary alcohol will not react immediately and they will not give instant turbidity of RCl. I hope that it is clear to all of you. The tertiary alcohol, this is CH3, right? And this is CH2 over N. So this is the answer. Got it? So this is very important question, very important reaction. And next is another very important reaction related to the breaking of CO bond, and that is what this reaction is. Ibrahim, can you read it out loud for me?
Acid catalyzed dehydration
Of alcohol. So what do you mean by this reaction? Just can you decipher it in simple words?
So basically the alcohol will be dehydrated in the presence of an
Yes.
acid.
Yes. So what do you mean by dehydration? What we are going to do it in this reaction?
Removal of
Dehydration
a
of alcohol.
hydrogen.
Removal of
Hydrogen. No,
hydrogen or
H2.
H2O. Yes. If we don't drink water in summer days, when we are sweating a lot, our body get dehydrated, right? Same alcohol may also get dehydrated. Not in summers, but alcohol will get dehydrated when they are heated with acids. Got it? Is it clear, Marwa? So it is the removal of water from alcohols. Dehydration. The removal of water, removal of OH and H groups. Is it clear, Aisha? Right? So
Yes.
what you need to do is H plus heat actually, because you are removing water, so take concentrated H plus. Don't take dilute H plus. Got it? So because if you take dilute H2SO, that will have a lot of water and the water will not be removed. Take concentrated H2SO4. Is it clear or not? The water will be removed and you will end up with an alkene. Is it clear or not? Write either write minus H2 over the arrow or write H2 as a product. And separately as a product means H2 is removed from the alcohol. It is not now OH is not there, you will end up with alkene. Got it? Any doubts in this? Is the reaction clear to all of you? Reaction is it clear? Alkene, preparation of alkene. Marwa, I hope you understood.
Yes, sir.
Okay. Concentrated or dilute, that we need to always keep in mind, because concentrated will lead to the removal of water. Which other acid you can take? So just let me write some alcohols and some acids. What is the product? You can tell me. This is ethanol. And when you heat it at 170 degrees Celsius, the temperature you need to remember it. Okay. This ethanol will get dehydrated and you will end up with ethene. Either write minus H2 over the arrow or write H2O separately. Clear? The other alcohols, the secondary and tertiary alcohol, will they react faster or slower than the ethanol? Jasleen, will they react more quickly or slowly than the ethanol? Can you compare the rates for secondary and tertiary? Yeah. This secondary alcohol. Right, Marwa?
Yes.
So, will it, Jasleen, just check it. All the reaction where you are removing the, breaking the CO bond. Are we breaking the CO bond or the OH bond? Just check it. Are we breaking the CO bond or the OH bond? Right. We are breaking the CO bond. And wherever the CO bond is being broken, whether it is a Lucas test or acid catalyzed dehydration, the pattern of the reaction is going to be same. Secondary alcohol will be more reactive. Tertiary will be most reactive. Primary alcohol will be least reactive, because this is related to elimination reaction, okay, and the formation of the carbohydrates, right? Just got it. So rate is going to be faster for the formation of propene is going to be more. Aisha, is it clear? Marwa, is it clear or not? Got it? It is going to be faster. But if you compare tertiary alcohol, that is tertiary ethanol, the rate is going to be further more than this isopropyl alcohol. Ibrahim, can you name the alkene? Ibrahim, are you there?
Yes, sir.
Yeah. What is the name of the alkene which is formed in this stage?
We have CH3 and then
Yes.
CH3, CH, CH2, CH3.
CH. Then
No, above we'll have CH3 and below one CH3.
above CH3 and below CH3. And
And that's it, yeah.
that's it. But you do not have 4 bonds on the carbon atom in the middle.
So
Rest
CH,
H.
CH will, yeah.
Is it okay?
Yeah.
No, just check it. What we are removing? Just check it once more. What we are trying to remove? Marwa.
Yes.
H and OH. Got it? And if you remove them, what will be the product? Marwa, can you see the name of the product and the characteristic?
Yes.
It is alkene. So, Ibrahim, what should we do now? How to correct it? Yeah, Ibrahim.
So we can put a double bond on one
Exactly.
of the.
Yeah, remove the hydrogen. Don't put the make one. Put one hydrogen less and make a double.
Yeah.
Yes. And there is yeah. You need to add something more to it, right, Aisha? So what is the name? 1, 2, 3. That is propene. 2-methyl propene. Got it? That is the IUPAC name of the product. Either write minus H2 over the arrow or write plus H2 as a product. Means water is now removed. Clear to everyone? Very simple thing. You need to take either concentrated H2SO4 or H3PO. Can I take HCl? Marwa, can I take HCl? Ibrahim, can I take HCl? Or HNO3 can I take? Or should I take H2SO4 or H3PO4 only? I can't take HCl, right? Because that will be Lucas reaction. We have seen it above. Got it? So H3PO4 or H2SO4, these are the two common acids which are used for the acid catalyzed dehydration of alcohols. Be careful. Very simple but very important for all examinations. All examinations it is going to be useful. Be careful about it. Okay, so very simple reaction. Got it? I hope this is clear. Rate of dehydration. Again, I am writing secondary, tertiary, primary. Okay. How it takes place? What's the mechanism? What's the mechanism? What do you mean by mechanism, Ibrahim? Can you tell me quickly? What are we going to show in the mechanism?
So the transfer of electrons within
Yeah,
different.
actually transfer of
Mhm.
electron in what sequence, which bond is broken and which sequence, okay. The whole sequence, internal sequence of the reaction, which is not represented in the chemical equation because that gives only the reactant and products. Okay. So the mechanism is, let's take the above alcohol only, the one which I have written above this one. OH is there. H2SO4 is an acid. All of us know that. It is going to release H plus, right? This H plus is going to get attached to the oxygen. Got it? Is it clear?
Yes.
And you have this OH2 being removed as water. This is oxonium ion. Got it? Once you have this oxonium ion, I'm going to write it in a condensed manner. It can lose water. Leaving behind a carbocation. Because if the water comes out, there was a positive charge. Why that positive charge came in? Because of the H plus which got attached to the OH. Right? Once the OH got converted to OH2 plus by the attachment of H plus, the OH2 plus got removed as a water and you had a carbocation. This is a slow step. And slow step is rate determining step. Got it? Is it clear or not? So what will happen to this? This is carbocation. So Ibrahim, is it going to stay as it is, or something else can happen to it? This carbocation, does it have complete bonds?
No, sir. It has one less bond here.
Yeah, there is a plus charge. We need to ultimately get it converted to some final product, which is the alkene. So what happens? You have a cation. This cation pulls the electron from the CH bond. You have CH bond, okay? And what you have now? You have CH3, CH3. Because it has pulled the electron, those electrons are now participated in the formation of a double bond. And you can see that only two H are there. Initially 3 H were there. 1 H is removed. So that's how the reaction has occurred. Very important, very important. Very simple also. Tertiary cations are more stable. That's why the tertiary alcohols will undergo dehydration most readily, most easily, most quickly. Got it. On the other hand, primary cations are unstable, so they are going to form with difficulty, and that's why for the primary cation the rate will be very slow. I hope it is clear to all of you now. Got it? Any doubts in this? So this is how your alkene is formed. Very important reaction. Okay, don't miss it. Just go through your NCRT also and just try the problems. And today I will be giving you more problems in the assignment also. So do them. All these reactions are very important, of top priority. Okay, you can't afford to forget them. Got it? So I hope your doubts are cleared in this, but your doubts will be completely removed if you try them once. Okay, you need to try yourself also and ask me in the next class. Okay, what are your doubts? Okay, every class we start with the quick recap